Did you know that if you scaled up the nucleus of a hydrogen atom to my size, that the nearest electron would be over 5 kilometers away? This amazing fact implies that
matter is mostly empty space.
Did you also know that this well-known factoid isn't true? That's right. Your understanding of the structure of the atom might be 100 years out of date. Let's get you up to speed. To the classroom!
Now entering the facility.
For whatever pedagogical imperative, most people's understanding of the structure of the atom stops here, with some big balls surrounded by smaller balls. Shush, Kevin, it's not funny. And with this representation in mind, it makes sense that you might believe a fun factoid like atoms are mostly empty space. But let's do a little reality check on those balls, shall we? Kevin, I said shush. It's not funny. Balls. In about 4 billion years, scientists predict that there's a 50-50 chance that the 1 trillion stars of the Andromeda Galaxy will collide with the Milky Way. This sounds like a cosmic catastrophe. However, space is really big.
Citation needed.
And stars are very far apart.
Citation needed.
So much so that scientists also predict that when these two galaxies come together, it's unlikely that a single star will collide when they do so. Not a single star out of a trillion. In fact, the galaxies are going to basically pass through each other until gravity brings them back together into some new stellar structure. Now, atoms are not spaced at the same scale as stars, but if they were in fact mostly empty, shouldn't a similar thing happen when, for example, you bring the galaxy of subatomic particles in your hand in contact with something else? Why doesn't your mostly empty hand pass right through your mostly empty phone that half of you are holding right now, like the Flash? Why can't you walk through walls like Harry Potter?
Really? Harry Potter in 2026?
You're right. We need to move on from that. Sorry. Well, you don't pass through things like Andromeda because despite what Dr. T here says,
atoms are mostly empty space.
No, atoms are not mostly empty space. We've known this fact for over 100 years now, but much like your father's fashion sense, the public understanding of the structure of the atom is stuck somewhere in the 1900s. So, to bring you all the way up to speed, we're gonna start from the very beginning. Kevin, get that out of your nose.
How did he even fit that in there?
I don't know. Actually, I'm kind of impressed it all fit in there. Aria, I would like to admit something to you and all the lovely people watching. About 2 years ago, my health physically was 99% empty. I had just exploded a finger while rock climbing, got depressed, I'd gained a bunch of weight, and I started feeling self-conscious about appearing in front of you and doing, my whole thing. Thankfully, that all started to turn around once I found the only personal training program that has ever worked for me. I can now happily say that for the last 2.5 years, I have been on an unbroken streak of 3 custom workouts a week. That is why I am honestly recommending the sponsor of today's video, Trainwell. Trainwell is a one-on-one personalized training service that is built to keep you consistent. Take a quick quiz to get your goals, connect with a trainer, tell them what equipment and gyms you have access to or not, everything is fully remote, and get back personalized workouts that your coach, like my coach Rod, can change, move, or augment at any time. Weight's too heavy, need more leg days, something tweak in your aging millennial body and you need to change the exercise now? No problem. The app also works directly with my smartwatch, perfectly timing my rests, playing my music, and letting me adjust weights and reps on the fly. But if I'm being honest, what really keeps me on Trainwell is how it gamifies my fitness journey. That just works with my brain. Just look at this fun little summary that I get every year. I lifted a total of 1.9 million pounds in 2025. That's like bench pressing 2 747s. I'm the strongest boy in the world. Using Trainwell has changed my physical and mental health dramatically. I honestly don't know where all of this would be right now without it. If you want to try it like I did, go to the link on screen right now or in the description to get 14 free days of personal training on me. Take the quiz, see if it works for you like it worked for me. I do actually recommend it. And hey, here's another quiz for you. How long did it actually take scientists to start probing the interstices of the atom? A lot longer than 2 years pumping iron, I'll tell you that. The first ideas that all stuff in the universe is made up of smaller, indivisible stuff were had a very long time ago indeed, when a one Democritus of Abdera, handsome guy, thought that all matter in the universe must be made up of individual particulates, and he named these building blocks of matter itself atomos, meaning indivisible. But it would be another 2,000 years before science was in a state where it could get the atom to fully reveal itself. Or thyself. I don't know how they spoke. The first real insights into the atom came shortly after the discovery of natural radioactivity in 1896. Just 1 year later, in 1897, physicist J.J. Thomson
That's not him.
was exciting different gases in glass tubes when he discovered that something was coming out of these gases that could be deflected by electromagnetic fields. More specifically, something negatively charged was being deflected by a negative charge. J.J. Thomson concluded
Why are you doing this?
that some part of the gas must be discrete and have an overall negative charge. We now call these particulates electrons. And because atoms are electrically neutral, Thomson proposed that these negative particulates must be embedded in something with all of the gas mass and an overall positive charge to cancel them out. Around the same time, physicist Ernest Rutherford
Why are you the way that you are?
was expanding on the work of Pierre and Marie Curie. He discovered that natural radioactive elements emitted at least two different kinds of radiation. The first had a lot of mass and was repelled by positive charges. He called these alpha particles. The second had the same charge to mass ratio as electrons and was repelled by negative charges. He called these beta particles, which were later confirmed to be high-energy electrons. Ernest would then go on to use these particles in one of the most famous science experiments of all time. To further question the composition of the atom, Rutherford took a source of alpha particles and aimed them at a sheet of gold. Gold was chosen because it can be hammered down to just a few atoms thick, minimizing the hot atom-on-atom action to make what might happen more clear. If J.J. Thomson was right, then the alpha particles should punch right through the electrically neutral, evenly distributed atomic pudding. But what actually happened was that the alpha particles were occasionally but significantly deflected onto a surrounding photographic film, sometimes directly back at the radioactive source. The only way this was possible was if the gold sheet contained an atomic structure that had the majority of the mass of the atom in a single positively charged location. Ernest would later call this the nucleus.
Can you give me legs so I can leave?
The famous gold foil experiment directly contradicted J.J. Thomson's ideas, and so, in 1911, Rutherford proposed this, a model of the atom not pudding-like, but instead with a central nucleus and electrons orbiting around it. However, this did not explain why negatively charged electrons wouldn't just spiral in to cancel out their charge with the positively charged nucleus. And so, just 2 years later, in 1913, a one Niels Bohr took some cues from new physics and proposed this, something that you are probably familiar with, the planetary model of the atom, with a central nucleus and electrons orbiting only at fixed positions around it. This is where most people's understanding of the atom stops, and I guess that is not surprising, because to bring our understanding of the atom all the way up to current knowledge, we have to include one of the most confusing but most powerful ideas in all of science: quantum mechanics. Hey, have you ever seen some self-help book or guru guy, because they're always guys, say quantum is the key to everything in your life? Well, this is just a new science-y spin on an old scam, and I can prove it to you. You've probably heard that a particle can act both as a particle and a wave, right? Well, this equation, first developed by Louis de Broglie, relates a particle's mass and its wavelength. Point and wave-like properties. Basically, the more massive a particle is, the smaller its wavelength, and it's less likely to interact like a wave with something of a similar orders of magnitude size. You can think of it like this. Imagine a tiny bathroom rubber ducky going down the Amazon River. Even though the little rubber ducky does make some waves, it doesn't really affect the entirety of the Amazon River's waves, right? For all intents and purposes, because it's so small, you can treat the rubber duck like a particle. Here's why the whole quantum thing is a scam. They say that quantum effects can be had at our human scales, right? Well, let's imagine a double slit experiment at human size. Let's get two normal doors, place them 1 meter apart, and then you go running at the center of them like an absolute maniac. You plug your mass and your average velocity into the de Broglie equation, and you get a wavelength that is 1 trillion trillionths of a meter. Much smaller than a meter, and so you are most likely to interact with those two doors like a particle and not like a wave, and you're gonna smash your face. Don't you feel stupid now? On the other hand, take an electron, which has a de Broglie wavelength on the order of the diameter of atoms, and so it interacts like waves with atoms. Simply put, we do not experience quantum-like effects, and you can't use them to buy a helicopter or a yacht or whatever, because our wavelengths are simply too small, our systems are simply too massive. No matter what Deepfake Chakra has to say, or whatever his name was. It was pretty redacted, so it was hard to read. Now, the model that you know, the planetary model, is pretty close to true. There is a central nucleus and there are electrons around it occupying only certain energy levels. However, once you start adding more and more electrons to this model for bigger and bigger atoms, aside from hydrogen, the model fails. Scientists would soon realize that the only way to make sense of the world at this scale is to include weird duality particle wave probability stuff. In 1924, Louis de Broglie built on the famous double-slit experiments over a century before and proposed in his PhD thesis that all matter has wave-like properties. Just 2 years later, in 1926, Erwin Schrödinger
I am calling the police.
applied the matter-wave idea to the structure of the atom, mathematically treating the electrons like waves. Now things get tricky. If matter is acting like a wave, then it can't have a single defined position like a planet orbiting a star. The Bohr model, right? Instead, there will be only a probability that, say, an electron will be in some spot when you go looking for it, and that probability depends on what its wave looks like. So you calculate what's called the wave function for a particle, proportional to the amplitude and size of its wave, and then you plot this function across higher and lower probabilities to see where the particle is likely to be. Do this and you get a visualization like this, with denser dots indicating higher probabilities. These regions that change size and density are called orbitals, and after another 100 years of study, we now know that these probability distributions can have many different shapes that are actually quite beautiful. So Schrödinger applied all of this to the structure of the atom and finally proposed the quantum model of the atom. No little balls, no defined orbits, but instead a cloud of probability around a nucleus that changes depending on the number of electron matter waves sloshing around, which ultimately determines how atoms interact with each other. This is why you can touch things without your hand passing through them. This is our most up-to-date understanding. I ask you, dear viewer, do you see mostly empty space in this model? No. Again, I understand why most people's understanding of the atom stops at the planetary model. It's much easier to understand than quantum mechanics. But if you're going to carry any factoid about the atom around for the rest of your life and maybe tell millions of people about something that is wrong,
Wait.
it's worth embracing just a little bit of quantum weirdness to get your understanding closer to the truth about this wonderful universe. Are atoms mostly empty? No. Reality is a lot fuller than that. Until next time.
Now exiting the facility.
Thanks again to Trainwell for sponsoring today's episode. Scan this code or go to this URL to get 14 days of free personal training on me. Thank you so much to the very nerdy staff here at the facility Man Bun for their direct and substantial contribution to the making of this video. If you want to join the facility, if you want a silky, slightly blonde man bun attachment, You can go to patreon.com/Kyle Hill, where you can get videos early, see all of our podcasts with ADEF, members only. You can get members only live streams with me. You can join our Discord. You can get discounts on merch, all of that great stuff. And if you support us just enough, you get your name in every single video where it makes sense. And as you can see, there are so many of you. Thank you. I don't know how I'm going to pass that. You ever wonder, I do, about little factoids that you like to say that turn out to not be true and you're just spreading misinformation? Atoms being mostly empty space is one of those, but here are some more. You do not eat 7 spiders during your lifetime. They don't want to crawl in there. Reflexology and chiropractic are based on ideas that have no physical or biological mechanism behind them that is plausible. Don't pee on a jellyfish sting. That will make it much worse. All I'm saying is double check yourself before you double wreck yourself. Possibly on a stage as the most famous scientist in the world. Bye.